In this video, we're going to do a few more examples involving arithmetic sequences. So remember, an arithmetic sequence is a sequence that can be defined with a first term, and then where the difference of two consecutive terms is some constant d. Or you can get to an by taking an minus 1 and adding some constant d, where d is the common difference. Okay, so I left this one, this example here. So it's maybe hard to tell what to add here. Okay, so I might want to do the difference of the two. So if I do 1/3 minus 1/2, I need to make a common denominator, which is 6. So for the first term, I need to multiply by 2, and for the second term, I need to multiply by 3. So that's going to be -1/6. So to get from the first term to the second term, I need to subtract 1/6. Okay, now does it, so this is A2 minus A1. So we could also just make sure if we do A3 minus A2, 1/6 minus 1/3 is going to be 1/6 minus 2/6, which is again -1/6. Okay, and then after that it's more obvious. So if I have 1/6 and I subtract 1/6, I get 0. If I subtract 1/6, I'm going to get -1/6. So that makes more sense. So here the common difference is -1/6 because I want to subtract those. Okay, so then if we wanted to write it with using the recursive definition, we would write, actually I'm going to call it B because the one above is A. So B1, that's the first term, that's going to be 1/2. And then Bn I can find by taking Bn minus 1 and subtracting our common difference, which was 1/6. Okay, so that's a recursive definition for this arithmetic sequence. So we have a formula for the arithmetic sequence. So remember, if you know it's an arithmetic sequence, then you should have an. Instead of using the recursive definition, a closed form definition would be A1 plus n minus 1 times d. Okay, now the next thing we want to do is how to show that a sequence is arithmetic. So for example 3 here, we want to show that this sequence is arithmetic. So I want to take two random terms. Okay, so I'm going to take Sn. Okay, so two general consecutive terms. Okay, so Sn I know is 3n plus 5. And the term before Sn minus 1 is 3 times n minus 1 plus 5, which is 3n minus 3 plus 5, so it's going to be 3n plus 2. So Sn minus Sn minus 1 is going to be 3n plus 5 minus 3n plus 2. So that's 3n plus 5 minus 3n minus 2. Okay, the 3n's cancel out, and 5 minus 2 is 3. Okay, so this is a constant. Okay, so it's our d value. Okay, so that means that the sequence Sn is an arithmetic sequence. Okay, since two general terms subtracted has a common difference, so a constant difference. Okay, now let's just check. Okay, so just to make sure, so S1 we know is going to be 3 times 1 plus 5, so that's 8. S2 is 3 times 2 plus 5, so that's 6 plus 5, so that's 11. And notice to get from 8 to 11, I would add 3. Okay, now S3 would be 3 times 3 plus 5, that's 9 plus 5, that's 14. And again, to get from 11 to 14, I would add 3. Okay, now this would give us intuition that it is arithmetic sequence, but it doesn't actually show it's an arithmetic sequence. It only shows the first 3 terms followed in an arithmetic pattern. Okay, so you want to be careful about that. But hopefully this convinces you that our work above, in fact, shows that it has to be arithmetic. Okay, so then if we wanted to find the sum of a terms in an arithmetic sequence, we derive these 2 formulas, okay, that we can use. So Sn is the sum, maybe I'll just write this here. So it's the sum of the terms, A1 to AN. Okay, so the first n terms. We add them all up. We can use this to find the sum. Okay, so let's do an example. So here we want the sum of the first n terms of this sequence. Okay, so first we want to show it's arithmetic. So if I call this AN, okay, so let's first show the sequence is arithmetic. Okay, so AN we know is 4n plus 3, and AN minus 1 is 4n minus 1 plus 3. So that's going to be 4n minus 4 plus 3, so minus 1. So that means that AN minus 1 is 4n plus 3 minus 4n minus 1. So that's 4n plus 3 minus 4n minus negative 1 is plus 1. Okay, the 4n's cancel out, and I get a 4, which is a constant, so that's my common difference. Okay, so that means that it is in fact arithmetic. So we can find Sn using the formula. So first of all, let's do A1. Okay, so that's 4 times 1 plus 3, so that's 7. Okay, so then Sn is going to be n over 2 times, okay, so I'm going to use this formula here. Okay, so it's 2 times A1, so 2 times 7, plus n minus 1 times our d value, which is 4. Okay, so that's n over 2 times 14 plus 4 n minus 1, which if you expand this through is going to be 7n plus 2n times n minus 1. Okay, so we could use this to find the sum of the first n terms. Okay, so that's a simplified version. Okay, let's try this word problem. So it says the first row in a corner stadium section has 10 seats. Okay, so the first row has 10 seats, but we're in a corner. So there's 40 rows in this section, and each row has 2 more seats than the row in front of it. Okay, so what this tells me, so A1, okay, so let's call the first row, okay, so the number of seats in it, let's call it A1. So we know that that's 10. Okay, now we know that the second row has, so that's going to be A2, it has 2 more seats than A1. So it's going to have 12 seats. Okay, the third row has 2 more seats than A2. So I take A2 and add 12. So that means that the nth row, so that's AN, is going to have the number that's in the row before plus 2. Okay, and this is for n. I guess n should start at 2. But it goes up to the 40th row. So there's 40 rows in this section. Okay, this is an arithmetic sequence. Okay, so this sequence is arithmetic. So look at the definition. So it's a recursive formula, and between we just add 2. So it's an arithmetic with A1 equals 10 and D equals 2, because we're adding 2 each time. Okay, so what we want, so it wants to know how many seats are in this section. So the number of seats in the section is equal to the sum of the 40 seats. Sum of the number of seats in rows 1 to 40. Okay, so that's going to be S40. So because I know it's arithmetic, I have the formula. Okay, so it's going to be 40 over 2 times 2 times A1. So A1 was 10. Plus 40 minus 1 times our D, which is 2. Okay, so that's 20 times 20 plus 39 times 2 is 78. So if I add those and multiply, I get 1,960 seats in total. Okay, now I'm just going to put a little line here. So I just want to show you that it's the same if you do it the other way. Okay, so or we could use that Sn is n over 2 times a1 plus an. Okay, so then we'd want to find an. Okay, so that's a40 because I want S40. So this is going to be a1 plus 40 minus 1 times d, which is 2. Okay, A1 is 10. So this is 10 times 39 times 2. So we get 88 there. So 39 times 2 is 78. Plus 10 is 88. So using the other formula, S40 is 40 over 2 times 10 plus 88. So that's 20 times 98. And again, you should get 1,960 seats. Okay, so just to show you that the other equation works the same, you just have to find the last term, so how many seats were in the last row, and then you can use this formula instead if you prefer. Okay, so it doesn't make a difference which one you do. So those are a few examples of arithmetic sequences.